Hello students, my today's lecture is about how to solve questions on binomial distribution and Poisson distribution. As you all know that binomial and Poisson distributions are both discrete probability distributions. So we shall try to understand how the questions on binomial and Poisson distribution are solved. Let's talk about binomial distribution first. Binomial distribution, that means it is binomial. It is divided into two parts. That means an observation or an experiment, whatever is considered in binomial distribution, has two aspects, has two categories. One category is of success and the other category is of failure. That means probability of success and probability of failure represented by P and Q. If I say that the probability of success of an event is 0.2, so I can say that the probability of failure is 0.8. 0.2 is nothing but 20% and 0.8 is nothing but 80%. The total of the probabilities has to be 1. That means success and failure are two complementary events. Complementary events means the total of the probabilities has to be equal to 1. That is 100%. So it is very clear that when we talk about binomial distribution, then we are having two aspects. One aspect is of success and the other aspect is of failure. Now let us talk about what is the parameter used in binomial distribution. In binomial distribution, x follows binomial distribution with two parameters, that is n and p. N and p. N is number of times the experiment takes place and p is the probability of success. So if we know the probability of success, we can easily get the probability of failure. So what do we need, or what all elements are required to solve a question on binomial distribution? There are three elements which are required to solve a question on binomial distribution. The elements are n, p and q. Suppose in the question the value of n is given as 4, the value of p, that is probability of success, is given as 0.2 and probability of failure we get as 0.8. So we are having n, p and q. So how we will find out the probability of a variable equal to, suppose 2, x equal to 2. Let us solve this question and then we can take a realistic example and we will apply this binomial distribution and try to understand that how a question on binomial distribution can be asked in the exam. In this question, I am going to make you understand that how by using n, p and q and by using binomial distribution, I can find out the probability of a variable of x which is equal to 2. Now remember, this is a discrete probability distribution. That means here the x has an exact value. X has an exact value. X is equal to 2. So 2 items are defective. 5 items are defective. 2 people are mad. 10 people are mad. That means we can count the number of items. We can count, we can have an exact value. That is why this binomial distribution is a discrete probability distribution. Now, how to solve a question on binomial distribution? Here, I can say that x follows binomial distribution with np, that is x has binomial distribution of n is equal to 4 and p is 0.2. The formula of binomial distribution is probability of x is ncx multiplied by p raised to x multiplied by q raised to n minus x. That is n. What is the value of n? 4. C. What is the value of x? X is equal to 2. multiplied by P. What is the value of P? It is 0.2 raised to X. What is the value of X? 2 into Q. What is the value of Q? 0.8. N minus X, that means 4 minus 2, that is equal to 2. Now 4C2, this is something called as combination. Now in combination, how to use this 4C2 or how to apply the formula of combination? It is NCR, n things taken R at a time, selected R at a time, is n factorial, R factorial, n minus R factorial. That means I am using this formula here, NCR 4C2, it is 4 factorial, it is 2 factorial, 4 minus 2 factorial, so it is 2 factorial multiplied by 0.2 into 0.2 is 0.04 multiplied by 0.8 into 0.8 is 0.64. Okay, so I will get 4 factorial means 4 into 3 into 2 into 1 upon 2 factorial means 2 ones are 2. 2 factorial means 2 ones are 2 into 0.04 into 0.64, that is equal to 2 2s are 4 and 4 gets cancelled. 3 2s are 6, 6 multiplied by 0.04 into 0.64. I'll multiply and I will get the answer of probability x equal to 2. 0.1536 is the answer. 0.1536 is the answer. Now this was an example question. Now I will take a realistic example. There are 10% defective items in a large bulk of items. What is the probability that a sample selected from 4 items include one defective item? It includes one defective item. Now here this question is related to binomial distribution, because here we are talking about the two aspects, defective and non-defective. And here the value of n, that is number of items selected, sample is taken, the sample is small, that is only 4 samples are selected. That means here always remember that whenever you solve a binomial distribution question, you need 2 parameters, that is n and p. So I will write how many items are selected, n, that is how many samples, 4. What is the probability of defective item? It is defective or it is non-defective. Binomial, defective or it is non-defective. So it is given in English. See, once again it is given, see there. There are 10% defective items in a large bulk of items. There are 10% defective items. So what is the probability of defective items? It is 10%, that is 0.1. That is 0.1. So if you get the probability of success, that is probability of defective item as 0.1, that means you will get the probability of non-defective item as 0.9. So probability of success is 0.1, so probability of failure will be 0.9. So we are having n, we are having p, we are having q. What is the variable? X is a discrete variable here. X is number of defective items. And what we are supposed to find, how many items are defective, which will include only one defective item. So which will include only one defective item. Only one defective item. So what we are supposed to find? We are supposed to find probability of x equal to 1. X is defective items. X is number of defective items. Now, solving the binomial distribution question. X has binomial distribution where 2 parameters n and p. So x follows binomial distribution, n is 4 and p is 0.1. P is 0.1. Now I use the formula. Probability of x is equal to n c x, p raised to x, q raised to n minus x. So here x is 1. So probability of x equal to 1 is n. N is how much? 4 samples out of n 4c 1, x is 1 into p is 0.1 raised to x 0.1 raised to x is 1 into q is 0.9 n minus x, that means 4 minus 1, that is 3. So I will get 4c1. You solve 4c1 by using this formula, ncr n factorial r factorial n minus r factorial. So you solve this, you will get 4 factorial 1 factorial 4 minus 1, that is 3 factorial. Always remember that 4c1 is always 4, 10c9 is always 10, 5c1 is always 5. Hope you understand. So 4c1 is always 4. You calculate, you will get 4. 4 into 3 factorial. 3 factorial will get cancelled. So you will get 4. Okay. Into 0.1 raised to 1 is 0.1. 0.9 into 0.9 into 0.9, use your calculators, you will get 0.729. So here you multiply 0.1 into 0.729 will be 0.0729. Multiply by 4, calculator pe you multiply, you will get 4 9 is 36, 6 3, 4 3 is 4 2 is 8, 9 10 11 1 1, 4 is 28, 9 2 4 0 2, 0.2916 is your answer. 0.2916 is your answer. If this question is asked as an MCQ type, I will be giving you 4 options. In that, this will be, I think, one option. Then you have to select that option and go ahead. Okay. You can also get the value of binomial distribution by the use of Excel. Now, because see, the exams will be online, and if you use Excel and you get the answer, that will also do. So here in Excel, how to find out the value of binomial distribution? You have to type equal to binomial distribution. Binomial distribution. When you type equal to and binomial distribution you type, then equal to and binomial distribution you type, and after typing binomial distribution, in the bracket there will be number written, that is sample whatever, then how many trials, then the probability of success, and then cumulative 1 2 3 4. So you have to write binomial distribution, double click on that. Number, now how many numbers, that means what to find. We were supposed to find 1 is to be defective, so you have to type 1, then comma. In how many trials? 4 defective items are to be selected, so trials are 4. What was the probability of success? It was 0.1, so 1 comma 4 comma probability of success was 0.1 comma. Now here they will ask you 2 questions. One is cumulative distribution and other is probability mass function. So if you remember, I had taught you probability distribution. In that I taught you that in discrete distribution we talk about probability mass function. So you have to click on probability mass function and press enter, PMF, and then press enter. You will get the answer 0.2916. Coming to the next part of today's video, we are talking about Poisson distribution. Now, when we compare binomial and Poisson distribution, you have to understand that these two distributions are discrete probability distributions. That means the value of x or the random variable is an exact number which can be counted. It is used in our real life in quality control statistics. That is normally in insurance sector, normally where we are supposed to find the number of defective items in a production process. We are supposed to find number of customers who visit a mall or a store in a given period of time. number of calls attended by a receptionist in a given period of time, number of cars passing through a signal. The parameter of Poisson distribution is mean. Mean is the parameter. M is mean. Mean or average is the parameter. If you see binomial distribution, there the parameter is NP. N is number of items. The difference between binomial and Poisson is, in binomial the value of n is small, but in Poisson distribution the value of n is or maybe too large. That is why n is not taken as a parameter in Poisson distribution. So in Poisson distribution only there is one parameter, that is m. We need to find the value of m and we will get the answer by using a formula. The formula of Poisson distribution is probability of x is e raised to minus m raised to x upon x factorial. So this is the formula of Poisson distribution, and when we compare binomial and Poisson distribution, you will find Poisson distribution solving more comfortable. More comfortably you can solve a question on Poisson distribution. So let's take an example question on Poisson distribution. Question number 1 of Poisson distribution. Defects on plywood sheet occur at random with an average of. Whenever we talk about Poisson distribution, we need one parameter, that is an average. Average, that is mean. Average of one defect per 50 square feet. Find the probability. We are supposed to find the probability that such a sheet has no defect. Now here, parameter is m, that is one defect. Parameter is m, that is one defect. We are supposed to find probability that the sheet has no defect. That means how many defects? No defect means 0 defects. So we are supposed to find probability of x equal to 0. Only one parameter we require, that is an average, and we are supposed to find probability of x equal to 0. Here x has Poisson distribution with m as 1. Probability of x is e raised to minus m raised to x upon x factorial. So e raised to minus m. So e raised to minus m is 1 into m raised to x, that is 1 raised to 0, x is 0 upon x factorial, means 0 factorial. So you will get e raised to minus m. So you cannot get e raised to minus m directly because the value of e is 2.718, but you cannot get it directly. So what to do? 1 raised to 0 is 1. 0 factorial is 1. So take this in the denominator, it will become e raised to plus 1. So 1 divided by e raised to plus 1 is 2.718. Raised to 1 is 2.718. So 1 divided by 2.718, you get on calculator 1 divided by 2.718, you will get as 0.3679. So there are 36.79% chances that there is no defects in the plywood sheet. Now this question can be solved with the use of Excel also. Okay, so I'll show you how to use Excel and get the answer of this question. So in Excel, how to solve this question directly, and you can mark the answer in your exam. You have to write equal to Poisson dot dist. When you type equal to and poi, then automatically the formula will appear there. You have to click on that, double click on that, sorry. You have to double click on that. So when you double click, there will be 3 options: x, mean and cumulative. 3 options. So Poisson distribution, x, what is the value of x? Is 0. What is the value of mean? Mean is 1. And cumulative means there will be 2 options. So x is x is 0, mean is 1, and cumulative there will be two options. One, it will be cumulative distribution function, and other will be probability mass function. What is probability mass function and cumulative distribution function? Already I have taught you in that probability distribution. If you have attended my lecture, then you all have understood that PMF is directly probabilities. Cumulative is from start, adding all the probabilities. Okay. So what we need the exact PMF. So here you will write PMF, probability mass function. So your answer will be PMF. Your answer will be 0.367879. So this answer is the same answer, 0.3679, rounded off. Okay. So we will take one more question and we will wrap off with binomial and Poisson. The average number of customers who appear at a counter of a certain bank per minute is 2. The average number of customers is 2. Find the probability that during a given minute, exactly 3 customers appear at the counter. During a given minute, exactly 3 customers appear at the counter. Now see, here we are going to use Poisson distribution. The average customers is 2. Okay. Now the value of n is not given. Maybe n is large. बराबर है? So we are going to use Poisson distribution. M is equal to 2. X is what? Number of customers who are appearing at the counter. Okay. M is 2. And what we are supposed to find? How many customers in 1 minute? Probability that during a given minute, exactly 3 customers. So probability of x equal to 3 we are supposed to find. So here once again x follows Poisson distribution with parameter m is equal to 2. Probability of x is nothing but e raised to minus m raised to x upon x factorial. So x is what? 3. So e raised to minus m, that is minus 2, m is 2, raised to x is 3 upon x factorial, that means 3 factorial. So what we will get? E raised to minus 2 will take it down. 2 2 is 4, 4 2 is 8, and e raised to 2 into 3 factorial means 3 into 2 into 1. 3 into 2 into 1 is 6. 2 4s are 2, 3s are. So I will get 4 divided by e raised to 2, that is 2.718 raised to 2 into 3. So I will get 4 upon 2.718 raised to 2. You will get 7.387524 multiplied by 3. You will get 22.162572. You divide it. 4 divided by 22.162572. Your answer is 0.1804. So your probability of 3 customers attending the counter is 0.18, that is 18%. Okay. The same values we will try to get in Excel, equal to Poisson, Poisson, DIST, dist. So you will get x, mean and cumulative, 3 values. Okay. So I will get Poisson distribution. So I will write equal to Poisson distribution. Double click on that. When you type equal to Poisson distribution, double click on that, you will get these options. So value of x is 3, mean is 2, and here you will get probability mass function, and you will press enter. So equal to x is 3, 2, probability mass function. Your answer is 0.1804. Okay. So this is your answer. So with this I stop. I have explained you all how to solve question of binomial distribution and Poisson distribution. My next lecture will be on normal distribution. Bye bye.